At this point, it becomes clear that the Moon is no longer just an object of curiosity or a scientific archive of the early solar system. It is turning into something else. A threshold. For decades, humanity treated the Moon as a destination, a place to reach, to plant a flag, to prove technological superiority, and then to leave behind. The Apollo era was driven by urgency, rivalry, and symbolism. Once those goals were achieved, interest faded. But the new wave of exploration tells a very different story. The data gathered by recent missions suggest that the Moon is not merely a silent witness of cosmic history, but a functional environment, harsh, unforgiving, yet surprisingly resource-rich. Water locked inside minerals, volcanic regions that remained active far longer than expected, rare isotopes embedded in the regolith. These discoveries shift the Moon's role from a scientific curiosity to a strategic foundation. A permanent human presence on the Moon would change how we operate in space. Instead of launching everything from Earth's deep gravity well, future missions could be assembled, refueled, and repaired in lunar orbit or on the surface itself. The Moon could become a staging ground, a place where humanity learns how to live beyond Earth for extended periods of time. More importantly, it would be a test. Life on the Moon forces us to confront realities we can ignore on Earth: limited resources, closed ecosystems, absolute dependence on technology, and the need for long-term planning that extends beyond political cycles or individual lifetimes. Every system would need to be reliable. Every mistake would be unforgiving. In that sense, the Moon is not just a stepping stone to Mars or beyond, it is a filter. A place where civilization either learns sustainability, cooperation, and patience, or fails early, before venturing farther into the solar system. This is why current lunar programs focus not on spectacle, but on continuity. Robotic missions today are mapping, sampling, testing, and preparing. They are doing quietly what human explorers once did dramatically, and in doing so, they are reshaping our relationship with space itself. The Moon is no longer the end of a journey. It is the beginning of a much longer one. Earth is a unique planet, not only because it hosts life, but because its behavior differs dramatically from other rocky planets in the inner solar system. And the key reason is its massive natural satellite. Venus, for example, is nearly identical to Earth in size and mass, yet it has no significant moon at all. Mars, though similar in many ways, is much smaller. Its two moons, Phobos and Deimos, are likely captured debris rather than true moons. Each is only a few tens of kilometers across, small enough to fit inside a single modern city. Gas giants present the opposite extreme. Enormous planets surrounded by massive moons. Jupiter, whose mass exceeds Earth's by more than 300 times, possesses moons comparable in size to our Moon. So a natural question arises: why does Earth, a medium-sized planet, have a satellite that is disproportionately large? When Apollo missions returned lunar samples, scientists were stunned to find how similar the Moon's rocks were to Earth's mantle. This ruled out the idea that the Moon formed independently elsewhere in the solar system. Instead, it suggested a shared origin. The most widely accepted model today proposes a colossal collision early in Earth's history. A Mars-sized protoplanet, often called Theia, struck the young Earth. The impact melted vast amounts of material, ejecting debris into orbit. Over time, that debris coalesced into the Moon. Modern computer simulations successfully reproduce many features of the Earth-Moon system, though some questions remain unresolved. In recent years, China has emerged as the world's leading force in lunar exploration. Unlike short-term missions, China is executing a long-term, carefully coordinated program designed for continuous data collection and progressive expansion. One region, in particular, has drawn intense interest: the far side of the Moon. This is not a dark side in the literal sense. It receives sunlight, but it never faces Earth. We cannot see it directly, and for most of history, it remained completely unexplored. In theory, the near and far sides of the Moon should be similar. In practice, they are strikingly different. The near side is dominated by dark volcanic plains, ancient lava flows that filled large basins billions of years ago. The far side, by contrast, is brighter, more heavily cratered, and appears frozen in a record of cosmic impacts. In 2019, the Chang'e 4 mission made history by landing softly on the Moon's far side. Its rover, Yutu-2, began exploring the von Karman crater, a massive structure over 180 kilometers wide, located inside the South Pole Aitken Basin. This basin is one of the oldest features in the entire solar system, formed more than 4.5 billion years ago. The impact that created it punched through the lunar crust, exposing material from deep beneath the surface. For the first time, researchers detected rocks that clearly originated from the moon's mantle, something the Apollo missions never encountered. At one point, U-22's camera captured an object with an oddly cubic shape. The internet erupted with speculation. Some jokingly named it the Moon Cube, referencing famous science fiction films. In reality, it turned out to be an ordinary rock, its strange appearance caused by lighting, shadows, and image resolution. But the episode highlighted something important. The far side of the moon still holds many surprises. Later missions went further. Chang'e 6 successfully collected samples from the moon's far side and returned them to Earth. For the first time in human history, scientists could directly study material from a region permanently hidden from view. The results were astonishing. These rocks differed significantly from all previously known lunar samples. They were lighter in color, denser, and showed fewer signs of volcanic activity. Some samples were dated to over 4.3 billion years old, the oldest lunar rocks ever found. Others were much younger, around 2.7 billion years old, far younger than most Apollo-era samples. This suggests that the moon remained geologically active much longer than scientists once believed. Even the classic giant impact theory no longer explains all observed data on its own. It is now clear that the moon is no longer just a distant object of study or a frozen archive of the early solar system. It is becoming something more. For most of modern history, the moon was treated as a destination, a place to reach, prove a point, and leave behind. The Apollo missions were driven by symbolism and competition. Once those goals were achieved, the urgency disappeared. Today, the approach is fundamentally different. Recent discoveries show that the moon is not only ancient, but also surprisingly practical. Water locked inside minerals. Volcanic regions that stayed active far longer than expected. Rare isotopes embedded in the lunar soil. Together, these findings suggest that the moon can support long-term human activity, not comfortably, but realistically. A permanent presence on the moon would transform how humanity explores space. Instead of launching every mission from Earth's deep gravity well, future spacecraft could be assembled, serviced, and refueled closer to space itself. More importantly, the moon would serve as a test environment. Life there would demand absolute efficiency, closed ecosystems, and long-term planning. Mistakes would not be theoretical. They would be immediate and unforgiving. In this sense, the moon is not simply a stepping stone to Mars or deeper space. It is a threshold, a place where civilization must learn how to survive beyond Earth before going any further. This is why modern lunar missions focus less on spectacle and more on continuity. Quiet preparation is replacing dramatic gestures. And with each mission, the moon moves closer to becoming not the end of a journey, but the beginning of one. Chinese lunar missions are no longer symbolic gestures. They are laying real foundations for humanity's future beyond Earth, not flags, not footprints, but infrastructure. If humanity is to survive and grow beyond a single planet, the moon will not be a destination, it will be a gateway. And now the question is no longer if we will return to the moon, but how soon and to stay. What do you think?